Coming to the applicability of an iterator pattern, it uses the iterator pattern to access and aggregate objects' contents without exposing its internal representation. And the next one is to support multiple traversal of aggregate objects and to provide a uniform interface for traversing different aggregate structures. That means that is to support polymorphic iterations. These are the three applicabilities we can say for iterator pattern. And then our next template is structure, and moving for the structure in iterator pattern is, this is the structure I considered for the iterator pattern consisting of 4 classes, and the first one is iterator, aggregate, concrete iterator, and the next one is concrete aggregate. And this iterator defines an interface for accessing and traversing elements consisting of first, next, is done, current item methods or operations, and the next one is aggregate. In this aggregate defines an interface for creating an iterator objects. These aggregate defines an interface for creating an iterator objects, and the next one is concrete iterator. And this concrete iterator implements the iterator's interface and keeps track of the current position in the traversal of the aggregates. And the next one is concrete aggregator. And this concrete aggregator does that it implements the iterator creation interface to return an instance of the proper concrete iterator. So, this is the structure for the iterator pattern. Based on this iterator, we can say that here we are going to involve 4 participants in this structure. Those are iterator, concrete iterator, aggregator and concrete aggregator. These 4 we can say that participants in this structure. We say that these 4 are the participants in our structure: iterator, concrete iterator, aggregator, concrete aggregator. So, our next template is collaboration. Coming to the collaboration, a concrete iterator keeps track of the current objects in the aggregate and can compute the succeeding object in the traversal. So, this is about the collaboration. A concrete iterator keeps track of the current object in the aggregate and can compute the succeeding objects in the traversal. And the next template is consequences. Coming to our next template, consequences, is the iterator pattern has 3 important consequences. The first one is it supports variations in the traversal of an aggregate. That means complex aggregates may be traversed in many ways. That means we can let us consider an example for code generation and semantic checking involve traversing parse tree. Code generation may traverse the parse tree in order or pre-order. Iterator may it easy to change the traversal algorithm. Just replace the iterator instance with a different one. You can also define iterator subclass to support new traversal. This is the first consequences. And coming to our next consequences, iterators simplify the aggregate interfaces. That means iterators travels interface meets the need for a similar interfaces in aggregates, thereby simplifying the aggregates interface. And the next one is more than one traversal can be pending on an aggregate. That means an iterator keeps track of its own traversal state. Therefore, you can have more than one traversal in progress at once. These 3 are the main or important consequences that we can speak under iterator pattern. And the next one is implementation. Coming to our next template, implementation. We have number of implementation that we can say under iterator pattern. Iterator may have implementation varieties and alternatives. Some important one follows. The first one is who control the iteration. A fundamental issue is deciding which party controls the iteration. The iterator or the client that uses the iterator. When the client controls the iteration, the iterator is called as an external iterator or else, and when the iterator controls it, the iterator is an internal iterator. That means the client uses an external iterator must advance the traversal and request the next element explicitly from the iterator. Coming to our next implementation, who defines the traversal algorithm? The iterator is not the only place where the traversal algorithm can be defined. The aggregate may define the traversal algorithm and uses the iterator to store just the state of the iteration. So, this is one of the implementation. And the next one is, how robust is the iterator? It can be dangerous to modify an aggregate while you are traversing it. If the elements are added or deleted from the aggregates, you might end up accessing an element twice or missing it completely. So, this is one of the implementation. Coming to the next implementation, additional iterator operations. The minimal interface to iterator consisting of the operations like first, next, is, done and current items. Some additional operations might prove yourself. And the next one is using polymorphic iterator in C++. Polymorphic iterators have their cost. They require the iterator objects to be allocated dynamically by a factory method. So, this is one of the implementation. Coming to our next implementation, iterators may have privileged access. An iterator can be viewed as an extension of the aggregate that creates it. The iterator and the aggregate are tightly coupled. And the next one is iterators for composites. External iterators can be difficult to implement over recursive aggregate structure like those in the composite pattern, because a position in the structure may span many levels on nested aggregates. And the next and the final one is null iterator. A null iterator is a degenerate iterator that is helpful for handling boundary conditions. So, this is the one of the main implementation. So, these are the 8 implementations we can speak under iterator pattern. The first one is who control the iteration, who defines the traversal algorithm, how robust is the iterator, additional iterator operations using polymorphic iteration, iterators may have privileged access, iterators for composite, and the last one is null iterator. These are the implementations for the iterator pattern. And the next template is known uses. First itself we said that these iterated design pattern mostly used by the .NET and Java developers, .NET programming environments and Java developers. So, these are the 2 main important known uses we can say under this iterator pattern. Iterators are common in object oriented system. Most collection class libraries often iterator is one from other. So, we have so many examples, so many real time examples for known uses. In that we are speaking about the main 2 uses are known uses are, the first one is .NET and Java developers, mostly using .NET and Java developers for this iterator pattern. Coming to our next template is related pattern. In this related pattern, we speak about composite, factory method and memento. These 3 patterns follow this iterator pattern. Composite, factory method, memento, these 3 patterns we say that related patterns to the interpreter pattern. These composite pattern are often applied to recursive structures such as composites. Iterators are often applied to recursive structures such as composites. This is the one of the composite pattern follows this iterator. And the next one is factory method. Polymorphic iterators rely on factory methods to instantiate the appropriate iterator subclasses. So, this factory method also says that it is a related pattern to our iterator pattern. And the next one is memento, is often used in conjunction with the iterator pattern. An iterator can use a memento to capture the state of an iteration. The iterator stores the memento internally. So, that this memento pattern also says that it is one of the related pattern to the iterator pattern. So based on all these templates, finally we say that this iterator pattern is that for accessing the elements in the container, elements in sequential manner without knowing the internal object data. The main thing and the main intent we speak for this iterator pattern is that you have a custom collections which is a complex object and you don't want to expose the internal of your complex object, and at the same time to provide a way to iterate of that object sequentially. So this is the intent of using this iterator pattern.